diagonalize the matrix 3 by 3 matrix is given. A is equal to 2, 1, minus 1. 1, 1, minus 2. Minus 1, minus 2, 1. By orthogonal transformation. By orthogonal transformation. So let us see how to solve this problem. First, the given one you have to write as A is equal to 3 by 3 matrix 2, 1, minus 1. 1, 1, minus 2. Minus 1, minus 2, 1. This is 3 by 3 matrix. So first you have to always find the characteristic equation. The characteristic equation is determinant A minus lambda I is equal to 0. So determinant A minus lambda I is equal to 0. That is, this can be written as lambda cube minus S1 lambda square plus S2 lambda minus S3, which is equal to 0, where S1 is equal to sum of main diagonal or principal diagonal elements. Sum of main diagonal elements. What are the main diagonal elements? So you can easily tell the main diagonal elements are 2, 1, 1. These are the main diagonal elements. So therefore 2 plus 1 plus 1, which is equal to 4. So S1 is equal to 4. So put in the box. Next you have to find S2. S2 is equal to sum of minor of main diagonal elements. Sum of minor of main diagonal elements. So let us see what are the minor of main diagonal elements. So the minor of main diagonal elements are, which is equal to 2. That is the first main diagonal element. Row wise, column wise eliminate. The remaining 2 by 2 matrix is minor of main diagonal element. 1, minus 2, minus 2, 1. Okay. So next plus next main diagonal element is 1. So row wise, column wise, for that element row wise, column wise you got to eliminate. So remaining is 2, minus 1, minus 1, 1. Okay. So next one is the main diagonal. Minor of main diagonal element is 1 is main diagonal element. For this you have to find the minor. Minor is 2, 1, 1, 1. So now if you are expanding this, 1 minus 4 plus 2 minus 1 plus 2 minus 1. So which is equal to minus 3 plus 1 plus 1. So minus 3 plus 2 is equal to minus 1. So therefore S3 is equal to S2 is equal to minus 1. So here S2 is equal to minus 1. So S2, which is equal to minus 1. Next you have to find S3. S3 is equal to determinant of the matrix. So determinant of the matrix. Given matrix A. So therefore you know how to expand this, which is equal to 2 into 1 minus 4 minus 1 into 1 minus 2 minus 1 into minus 2 plus 1. So matrix expansion, you have to find the determinant value. So here 2 into 1 minus 4, which is equal to minus 3, minus 1 into minus 1, minus 1 into minus 1, so which is equal to minus 6 plus 1 plus 1. So S3 is equal to minus 4, right? S3 is equal to minus 4. So next, to S1 we have got, S2 we have got, S3 also we have got. So you have to substitute in the characteristic equation. Lambda cube minus S1 lambda square plus S2 lambda, S2 is minus 1, minus S3 lambda, so that is a plus 4 is equal to 0. So this is the characteristic equation. So next you have to find by trial and error method, taking or put lambda is equal to 1. 1 means 1 cube minus 4 into 1 square minus 1 plus 4, which will be 0. So 1 is one of the root. If 1 is one of the root, using synthetic division you can find the values. So therefore lambda cube coefficient is 1, lambda square coefficient is minus 4, lambda coefficient is minus 1, constant term. So 1, 0, if you are adding these two, 1, 1, minus 4 plus 1 minus 3, minus 3 into 1 minus 3, minus 3 minus 1 will be minus 4, so minus 4, it will be 0. So therefore this can be written lambda square minus 3 lambda, right? Lambda square minus 3 lambda minus 4, which is equal to 0. So this can be solved. Lambda minus 4, lambda plus 1, which is equal to 0. So lambda is equal to minus 1 plus 4. So what are the eigenvalues? Eigenvalues are lambda 1 minus 1 4. These are the eigenvalues. Next you have to find the eigenvector. To find eigenvector, so what is the formula? The formula is a minus lambda I into x is equal to 0. So therefore a minus lambda I can be written as 2 minus lambda, 1 minus 1, 1 minus lambda, minus 2, minus 1 minus 2, 1 minus lambda into x1, x2, x3, which is equal to 0. So this is the formula to find the eigenvector. So what are the eigenvalues we are having? 3 eigenvalues we are having. So for the first eigenvalue 1, we have to find eigenvector. So let us see how to find the eigenvector. So therefore when lambda is equal to 1, when lambda is equal to 1, so when lambda is equal to 1, you have to substitute for lambda 1. So 2 minus 1, right? 2 minus 1, 1, 1 minus 1, 1, 1 minus 1 0, 1, 1 minus 1 0, minus 2, 1 0 minus 2, minus 1 minus 2, 1 minus 1 0. So first one into x1, x2, x3, which is equal to 0. So therefore you can multiply this 1 into x1 plus x2 minus x3, which is equal to 0. x1 plus 0x2 minus 2x3 which is equal to 0. Next one is minus x1 minus 2x2 plus 0x3 which is equal to 0. So take this equation number 1, equation number 2, equation number 3. So solving these three equations you will get x1 divided by x2 divided by x3 divided by. You have to write in this way. First I am taking these three equations are distinct, that's why I am taking any two equations. I am taking 1 and 2. What is the coefficient of x1? 1, x2 coefficient 1, x3 coefficient minus 1. Second equation x1 coefficient 1, x2 0, x3 minus 2. First two you have to repeat 1 1 1 0. First one cancel it. Remaining you multiply this one minus 2 0. Next you multiply this minus 1 plus 2 minus or minus 2 0 minus 1. So therefore the eigenvector is x1 divided by minus 2, x2 divided by 1, x3 divided by minus 1. Right? So therefore x1 eigenvector x1 is equal to minus 2 1 minus 1. Eigenvector x1 is equal to minus 2 1 minus 1. Next, when lambda is equal to minus 1, already we have got the eigenvector for lambda is equal to 1. Now for lambda you got to substitute minus 1. So 3 1 minus 1, 1 2 minus 2, minus 1 minus 2 2 into x1 x2 x3 which is equal to 0. So now if you are expanding multiplying you will get 3x1 plus x2 minus x3 which is equal to 0. x1 plus 2x2 minus 2x3 which is equal to 0. So minus x1 minus 2x2 plus 2x3 which is equal to 0. Take this equation number 3. So first two I am taking to solve to find the value of x1, x2, x3. Okay, I am taking first two. So suppose if you are taking second and third equation also you will get the same answer. So x1 coefficient 3, x2 coefficient 1, x3 coefficient minus 1. First equation. In second equation x1 coefficient 1, x2 coefficient 2, x3 coefficient minus 2. First two you have to repeat 3 1 1 2. First one eliminate. Now you have to multiply minus 2 1 into minus 2. Minus of minus 2 will be plus 2. Next you have to multiply these two minus 1 plus 6. Next you have to multiply these two 6 minus 1. So therefore you can write x1 divided by 0, x2 divided by 5, x3 divided by 5. So therefore the eigenvector x2 is equal to 0 1 1. 0 5 5 can be written as if you are dividing by 5. Okay, 0 1 1. This is x2. Next one x3, right? So when lambda is equal to four, case 3, when lambda is equal to 4, so minus 2 1 minus 1, 1 minus 3 minus 2, minus 1 minus 2 minus 3 into x1 x2 x3, x1 x2 x3 which is equal to 0. So now if you multiply minus 2 x1 plus x2 minus x3 which is equal to 0. Take this equation number 1. x1 minus 3x2 minus 2x3 which is equal to 0. Take this equation number 2. Minus x1 minus 2x3 x2 minus 3x3 which is equal to 0. Take any two equations. I am taking always first two equations. So x1 divided by x2 divided by x3 divided by x1, x2, x3 value we are going to find. So next, the coefficient of first equation, coefficient of x1 is minus 2, coefficient of x2 is 1, x3 is minus 1. Coefficient of second equation, coefficient of x1 is 1, x2 is minus 3, x3 is minus 2. First two you have to repeat, minus 2, 1, 1 minus 3. First one you eliminate. So this is minus 2, minus 3, minus 2, minus 3, minus 1, next one is minus 4, next one is 6 minus 1. So therefore this will be x1 divided by minus 5 which is equal to x2 divided by minus 5 which is equal to x3 divided by 5. So therefore eigenvector x3 which is equal to, if you are dividing by 5 you will get minus 1 plus 1. So this is eigenvector x3. Okay, so every value we have got. So after that, normalized vector for what we have got, x1, x2, x3. Okay, x1, x2, x3. So I am going to write the x1. So what is the x1? x1 is equal to the eigenvector. x1 is equal to minus 2, 1, minus 1. The eigenvector x2 is equal to 0, 1, 1. Correct? x3 is equal to eigenvector minus 2, minus 1, minus 1. The eigenvector x3 is equal to minus 1, minus 1, 1, minus 1, minus 1, 1. Now you have to write the normalized vector. Normalized vector. You got to find a normalized vector for each eigenvector. How to find? That is, I will tell you. The n is equal to minus 2 divided by square root of minus 2 square plus 1 square plus minus 1 square. In the same way, 1 divided by square root of minus 2 square plus 1 square plus minus 1 square. Okay, so minus 1 divided by square root of minus 2 square plus 1 square plus minus 1 square. What will be the value? So normalized vector value is equal to minus 2 divided by root 6, 1 divided by root 6, minus 1 divided by root 6. This is normalized vector for x1. Like this, x2 is equal to normalized vector is 0, 1 by root 2, 1 by root 2. Right? Do you understand? I think you understood. I think minus 1 divided by root 3, minus 1 divided by root 3, 1 divided by root 3. This is the way to find the normalized vector. Okay, now I am writing the normalized matrix. Normalized matrix. So normalized matrix is n is equal to minus 2 divided by root 6, 1 divided by root 6, minus 1 divided by root 6. Next normalized vector is 0, 1 divided by root 2, 1 divided by root 2. Next normalized vector is minus 1 divided by root 3, minus 1 divided by root 3, plus 1 divided by root 3. This is a normalized matrix. So you know very well n transpose. N transpose is equal to, simply we can write first row first column. So minus 2 divided by root 6, 0, minus 1 divided by root 3. Second row second column, 1 divided by root 6, 1 divided by root 2, minus 1 divided by root 3. Third row is a third column, minus 1 divided by root 6, 1 divided by root 2, 1 divided by root 3. This is normalized matrix. Now the diagonalize is, the formula for diagonalize is n transpose a n. This is the diagonalize formula, n transpose a n. So therefore first I am going to find a n, which is equal to, a is that is given in the problem, 2 1 minus 1, 1 1 minus 2, minus 1 minus 2 1. Next the normalized vector, minus 2 by root 6, 0, minus 1 by root 3. Next 1 by root 6, 1 by root 6, 1 by root 2, minus 1 by root 3. Next minus 1 by root 6, 1 by root 2, 1 by root 3. So first row I am taking, multiplying with first column. So therefore an value is equal to minus 2 by root 6, because minus 4 plus 1 plus 1. So minus 4 plus 2, which is equal to minus 2. So minus 2 divided by, denominator is root 6. 0, you have to multiply, matrix multiplication, minus 4 by root 3. So I am multiplying two matrices. So second row is 1 by root 6, minus 1 by root 2, minus 4 by root 3. Third row is minus 1 by root 6, minus 1 by root 2, 4 by root 3. Okay, so this is an value. Next you have to find the diagonalized matrix is equal to, D is equal to n transpose a n, which is equal to, what is n transpose? That is already we have written, minus 2 by root 6, 1 by root 6, minus 1 by root 6, 0, 1 by root 2, 1 by root 2, minus 1 by root 3, minus 1 by root 3, plus 1 by root 3. Okay, this is n transpose into an, that is just now we have got the result, minus 2 by root 6, 0, minus 4 by root 3, minus 4 by root 3. So therefore 1 by root 6, minus 1 by root 2, minus 4 by root 3, minus 1 by root 6, minus 1 by root 2, 4 by root 3. Okay, so if you multiply these two, you will get first row, you have to multiply with first column, minus 2 plus 4 by root 6 root 6 root 6 root 6, if you multiply 6, 4 by 6, 1 by root 6 1 by root 6, 1 by 6, so 4 by 6 plus 1 by 6 plus 1 by 6, 6 by 6, right? So answer is 6 by 6, that is 1. Next first row second column 0, first row third column 0, second row first column 0, second row second column is minus 1, second row third column is 0, third row first column is 0, third row second column 0, third row fourth column is, third row third column is 4. So this is D value. Okay, already you have written here D, so therefore this is diagonalized.